Good evening, everyone. My name is Sylvain, and I'll be your host for tonight. And with the whole team from Le Wagon, we have Douglas here, Sasha, Jan, Trini, and many more who could not be here tonight. We're super happy to welcome you for this very first part-time data science bootcamp demo day. So why am I saying the very first? Well, this was the first time that we were holding a part-time data science bootcamp. So for those of you who don't know what we are doing here at Le Wagon, we actually are offering two programs. One is a web development bootcamp, which is the historical bootcamp that we've been running for the past 5 years. And more recently, starting from almost a year ago, we launched a data science program. We've been running it full time, and for the first time 6 months ago, we also started a part-time program. So tonight, what you will be witnessing is what our 6 part-time students managed to deliver after 5 weeks of final projects. So you will be seeing their final projects. We will have 2 pitches for tonight, and I can tell you that they are really exciting. I hope you're all excited. Everybody's looking at me like, we're not excited. You guys are excited? Okay, there we go. Cool. But before we dive in the pitches, we also have a big surprise for you tonight. So as you may know, maybe some of you are used to our web development projects. And for web development projects, the ideas for the projects are coming directly from our students. This is also true for our data science bootcamp, but we have a small twist for some of our data science projects. What we do is that we invite some companies to submit their data, to submit their project, so that our students can pick that project and work on it for the duration of their final project. And so tonight we will have one pitch for which the data has been submitted by a company. This company is Listenfield, and what they're doing is really cool, but I'm not the right person to talk about it. So to talk about it tonight, we are extremely happy to welcome Rassarin joining us from, I believe, Thailand. I believe Rassarin is in Bangkok, I'm guessing. And she's going to be talking a little bit about her company and what they are doing to revolutionize the agriculture. So without further ado, I'd like to welcome Rassarin for her presentation.
Thank you very much, everyone, and thanks for having me here today. I hope everyone stay safe and healthy wherever you are. And yes, I'm calling from Thailand. And today my talk will be a bit more on like how I, as a co-founder, start Listenfield, more than just like what Listenfield are working on, by believing that we can inspire the data scientists who come to this part and see that it can be a way that everyone can try. I'm delighted to be here to tell you about my story. It is a story about how the company I co-founded, Listenfield, intend to use technology to make life better for farmers and for the rest of us. We believe that our precision farming ecosystem will help farmers produce more clean food in the way that is friendlier to our planet. I was a good student, but never the best. I did not like the routine of starting in the sun for assembly for each morning before school begins. So I tried to sneak over the school fence just before the class begins, which was not a good long-term strategy. So I found a better way. I volunteered to help look after school computers every morning. It was from that I learned to write antivirus computer programs. Programming is still an important part of my life to this day. One thing led to another, and one day I found myself with a degree in computer studies from King Mongkut Institute of Technology, Lat Krabang in Thailand. And then I graduated from Asian Institute of Technology, or AIT. My research was advanced image processing technology to convert two-dimensional digital images into accurate three-dimensional shapes of coral. In doing so, we were able to monitor the growth and determine the health of coral reefs. I then turned my interest to agriculture. One of the projects that I found is on broadcasting real-time information about the images and spinach fields growing in Qingdao, Thailand to Japan consumers at the University of Tokyo. Our sensor measures soil acidity, availability of water, temperatures, and moisture in the air. In addition, our technology helps to anticipate change in weather patterns. And why is this important? Japan used to import spinach from other countries, but found chemical residues and needs to find other source of supply. When proper processed and interface and analyzed, the Qingdao images and information allow Japanese consumers to see with their own eyes how we in Thailand grow fresh organic spinach using the minimum amount of fertilizers. We won the confidence of Japanese consumers. They know the source of supply and can see the spinach plants in the fields in real time. In short, our technology empowered huge-tribe farmers in Thailand to grow clean organic spinach that won Japanese consumer confidence. The project also attracts such a wide interest that more Japanese academics visit the area. They carry grant more scholarship to huge-tribe children to further their education. And from this, I received the scholarship to join the PhD scholarship in Chubu University, and Professor Kiyoshi Honda was my advisor and now turned to be my co-founders. And my thesis topic was API integration platform for agronomic models. Definitely it's not a catchy title, but we believe that our work could be an important contribution to precision agriculture because it provides insights into three things that are most important for all plants. First is soil. Japan already surveys and determines the quality and the profile of the country's topsoil, the top 15 centimeters. Using this data and deeper soil sample, I built what I call soil fusion model that assess the soil profile deeper to 60 centimeters anywhere in Japan. And this information allows everyone to access using API. Second is climate and weather conditions. For this, we use 30 years of climatological data as the benchmark. This weather pattern data is used to more accurately predict seasonal weather conditions at precise location. With the help of on-site sensors, these sensors monitor rainfall and combined with past data can be used to anticipate short-term trends. They also monitor moisture and other factors that are important for plant growth. That is, our model will provide the detailed and timely data on climate conditions, as well as their outlook at precise location anywhere in Japan. And the third one is cultivar coefficient. It means that plant is with their unique genotypes will grow and reproduce differently in response to changing environmental conditions. The cultivar file that Listenfield put together can help to tell you how your plants are growing under prevailing conditions. Even better, we can also tell you how your crops will turn out if they're fed differently or if climate and soil condition change. It is as if you have X-ray vision and can see the food being digested and how this food is making your body grow. And put all these together, we also combine with satellite imagery. We are now having a powerful platform to produce actionable data. Farmer would be able to improve crop yield using the right amount of fertilizers at the right places and at the right time. And for further develop and apply our technology, we set up Listenfield Japan. The name Listenfield reflects our realization that nature has always been trying to tell us many important things, if only we could know how to listen. Taking things one step further, Listenfield is also looking at DNA sequencing of plants. The way this interacts with environmental conditions can produce quality in fruit and vegetable that we design, like freshness, texture, taste, nutritional contents, and so on. And today we are a team of 20, and 50% of our team is female from 7 nationalities. We are now providing our service to over 10,000 farmers in 5 countries: Japan, Thailand, Vietnam, India, and in the US. And last but not least, I want to say that where you come from need not matter. You can decide what you do today and every day to define your life tomorrow. So find out what fascinates you and stick with it. Promise yourself, as I have promised to myself. The promise is live your life in the way that makes this world a better place. Find time to be nice to yourself, but always be nice to your neighbors. And please listen to what our planet is telling us. Thank you very much.
Tonight we also have one pitch that was built in collaboration with Listenfield. So without further ado, we're going to be jumping in that pitch. I believe that everybody is ready. Right. I'm looking at you, Yuki. Awesome. Cool. Let's welcome Yuki for the project in collaboration with Listenfield Skycrop.
Today I'll be presenting our project called Skycrop. Before we start, I'd like to acknowledge that this dataset was provided by Listenfield. Without them, our project wasn't possible. Thank you. So let's say that you are a rice or sugarcane mill owner, and you want to start a business in a new region. To optimize your business, what kind of information do you need? You'll need to get the up-to-date data about which crops are being grown in individual fields locally. With this key data, then you could estimate meal crop input amounts and how much fertilizer or pesticides to sell, and determine the size of mill and the required investment. To get up-to-date data about individual fields, of course, you can use existing government databases. However, the problem is that government databases are generally not up-to-date. So you need to create a new database. But it takes a lot of time to create a new database. Also, visiting each field on foot can even be unwelcomed in a state of COVID. The solution to these problems is our app, Skycrop. Skycrop can identify crop types remotely using the latest data at a lower cost. So this is our solution roadmap to address client needs. First, segment field. Second, identify crop types being grown in real time. Third, estimate production amounts and amounts of fertilizer or pesticides to be sell to farmers. Due to time and data limitations, in this project, we focused on the second target, to identify crop types. The data we used was satellite imagery taken by Sentinel-2 and provided by Listenfield. We got rice field imagery in Vietnam and Thailand, and sugarcane imagery in Thailand. As you can see, it looks impossible to distinguish field types by looking at field image. And this is why we need satellite imagery. The advantage of using satellite imagery is it contains more information. Satellite imagery has 13 bands. A band means something like a color, and human eyes are sensitive to only 3 of these bands. That means a satellite can see the colors that human cannot see. And these bands are suitable to assess vegetation. This is what data samples look like. One important reason why rice and sugarcane field band colors are different is because of the differences in vegetation intensity between the 2 examples. We extracted numeric information and used it to train our model. We found that combining numeric information of different bands improved our model score. One example is false color. False color is useful for visualizing areas of dense vegetation and for identifying vegetation types. We trained our model and achieved accuracy 95%. This strong classification performance was mainly because of using in all individual bands, not just band combinations. We tested our model on Japanese rice field too, and we got 83% accuracy. And our model doesn't consider location as feature for now. Now let's try our sky crop. So you need to upload a GeoTIFF file. A GeoTIFF file is an image file containing geolocation data. Yes, and once you upload an image, you're gonna see this is a Vietnam map on the left, and it's showing the location of the field. On the right side, it's the field image. Now let's play a game. Who think this image is rice field? Right. Okay. Then who think this is sugarcane field? Okay, like 50%. Okay, then let's classify. Yeah. And our model is calculating. The answer is rice field. Okay, let's try another example. Let's upload a TIFF file. And this time the location is Thailand. And who think this image is rice field? 1, 2. So who think this is sugarcane? Oh, okay, sugarcane. Let's try. And it's sugarcane. Thank you. Okay. Yes. Let's skip. But yeah, the main challenges we faced during this project was the complexity of satellite data. Since it was our first time using satellite data, extracting band data, creating band combination, and pre-processing was challenging for us. Things we would like to try next include increasing the number of classes and expanding our model to new geographies such as Southeast Asia, Indonesia, and India. These countries produce a lot of agricultural exports, including rice and sugarcane. These are my teammates, Hon, David, and I'm Yuki, the project leader. Thank you.
Our next team is ready to pitch, ready for you. Without further ado, let's welcome our second and final pitch for tonight. Give me some credit. Let's invite Mohit on stage.
Hey everyone, good evening. How's it going? So tonight my team and I are going to present our project that is called Give Me Some Credit. So to set some context, this project is aimed for banks or credit card companies who are going to be issuing lots of credit cards. And with these credit cards, there can be a scenario called churn. So what is churn? So churn means a customer just unsubscribes to that credit card and stops using it. So as we will see in our mission statement, the churn comes with a cost because the customer is paying some subscription fees for a credit card, or there are other commission fees which bank is making every time credit card is used. So it's a loss-making thing when a customer churns. So in this project, we are going to see what can we do to solve this problem. So first of all, let's have a look at the data that we have. We have received a data set from Kaggle for more than 10,000 people. So we have a split of male, female, then we have different data like income category, then we will be seeing what is the education level, what's the marital status, and if we go further, we will see the age groups, then there are some other financial features, and finally the churn. So out of our 10,000 plus customers, about 16% are churning. So our focus is that 16% and to see how can we predict the churning before it happens and take some necessary action. So for this, we have taken the machine learning approach. So I'll explain step by step what has been done so far. So first is the data exploration, as we have already done. The next step would be data cleaning and pre-processing. So it involves various steps. One of them is balancing, because we saw that 84% are not churning and only 16% are churning. So we have to balance that for the model to be working correctly. Then there are things like encoding, etc. Once we have done the pre-processing, then we have to try, okay, this classification problem can be done by various machine learning models. So which one should we use? So we tried it on various models and then selected the best model. Once we did that, we also realized that these customers have lots of features, like a lot of data for every customer. Some data is more important than other. So we have to find out which is more important and which is least important. And finally, when we have all of these things, we put our model into production and build a front end and user interface. So now let's go to the next slide and see what's being done. So over here, we are seeing the 4 models that we tried. Logistic regression, the most basic one. Then we tried KNN, SVM, and random forest. So what we are seeing here are precision recall curves of each of the models. So to explain it very, very simply, the larger the area under the curve, the better the model is performing. So over here, we can see that the area under curve score for our random forest model is highest, which is why we have chosen that model. Now, time to look at our features. So from top to bottom, we can see that some features have very high importance on our model, while some features are not so important. So we have highlighted 7 features at the bottom, which we are not taking, and we are dropping them because it's not making any significant difference to our model. So let's look at the comparison before and after. So on the left side, we can see the before, and right side is after. And as we can see, our metrics have not deteriorated, but in fact, one of the metric, precision, has improved after dropping the features. However, our current metric for the classification is recall, because recall allows us to reduce the false negative, which is what we are interested in doing. So now, after explaining all the technicalities and under the hood, now we will do a simple demonstration of how our app works. So this is our page, and we have two options. One is uploading a CSV file, and the other one is uploading a customer data manually. So let's try the manual one first. So here we have already loaded data of a person who is 62 years old, has 1400 something revolving balance, uses credit card 55 times in a year, and spends about $2,000 per year. So let's predict what this customer will do. Okay, so we found out that this customer is going to churn. And with that, we also have the recommendation that if we encourage the customer to increase the transaction count and amount by 0.1x or 10%, then we can prevent this person from churning. So later we will see how we can do that. But now also let us try to see the CSV feature, because a bank will be predicting on thousands of customers at once. So this CSV file has data of 5 customers, and let's see what the model tells us. So 3 out of 5 customers are going to be churning, and now it will display the result for all 3 of them one by one. So we can see that these 3 customers are churning, and we have a different prediction for each one. So first is 0.3x or 30%, second is 3.3, and the last one is 0.2. So from this, we can also make another decision that the 30% or 20% increase is realistic and can be achieved with some effort, while a 330% increase is something very difficult. So we may choose to ignore that customer and just focus on the lower hanging fruits. So now let us see how the recommendation is going to work. So from our previous slide for features, we have already seen that the transaction count and transaction amount are 2 of the most important features. So how can we do that? How can we make those numbers go up? The answer is make the customer use the credit card more. To do that, we can offer some exciting perks, like waive off transaction fees for a certain amount of transactions, offer cashbacks, have some rewards, or some other kind of promotional campaign. So if we do this, we will be able to increase those numbers and make sure the customer doesn't churn. So this is what we have done so far, but there's also what we can do in future. Our proof of concept is limited by the data set that we have, but if we have more data, we can do other things. For example, value of a customer. So every customer is going to add some value to the bank and also cost some resources to the bank. So if we have these data, that what is the value to cost ratio for customer, then we can decide, okay, this customer is worth pursuing for churning, or this customer is not worth pursuing. Then every organization has limited resources. So what's more beneficial? Is it to acquire new customers and spend your time and energy there, or maybe focus on the existing customers and stop them from churning? So that is another thing we can figure out. And again, there's one more called recommendation cost. So as in the previous slide we saw, there are different ways of preventing a customer to churn, but each one has a different cost. So for a specific customer, which is the best method to be employed? So that can also be one of the possibilities. So with this, I would like to conclude my presentation and introduce my team. So we have Mirko, Jocelyn, and myself, Mohit. And this was our project. And now we will be taking your questions. Thank you.